Hello everyone, welcome to Aptitude Made Simple. Today we are going to learn basic topic, that is type of numbers. So you may be working in any of the industry, maybe software industry, manufacturing industry, or any financial thing. But what usually happen, we focus on advanced thing more and we basically ignore or forget the basic things. So let's assume that if switch on the fan at home and it is not getting started. So what is the most basic thing we should check? We should check that whether we have electricity at home or not. Is there a power cut or something like that? And then you will check whether that switch is impacted, like it is having any fault, that fan switch. And then you will check whether the connection from that switch to fan is having some issue or not. So in maths also, we learn a lot of advanced topic. We learn trigonometry, we learn statistic, etc. But we forget basic or we really ignore them, like a type of numbers also. So today we are going to look at the type of numbers. So let's start. Natural numbers. So anything which is used for counting. So if you look at, if you count chocolates, there are 10 chocolates. So how you start counting? You always start from 1, 1, 2, 3, 4, like that. We don't consider 0. So anything which we use for counting, that is called as a natural number. So 1, 2, 3, 4, it will continue like this. Then we will see whole numbers. 0 along with the natural numbers is called as whole number. So it says 0, 1, 2, 3, 4, it will continue. Okay. Let's look at the integers. So positive numbers, negative numbers, and 0. This together makes it integers. So if you look at this 0, then you have positive integers 1, 2, 3, 4. It will continue here. And on the left hand side, you will have -1, -2, -3. It will continue on the left hand side, like the way we have on the right hand side for positive numbers. It will continue here on the left hand side also. So 0, positive 1, 2, 3, 4, and then negative -1, -2, -3. These are called as integers. Then let's look at factor. So if I write number 10, so can you tell me by which number 10 is completely divisible? So if we try to divide 10 by 1, we will get the remainder 0. So we can say that 1 is the factor of 10. Then let's take 2. If we divide 10 by 2, we'll get remainder as 0. 2 5s are 10. Then 3, we will get remainder 1. So that is not a factor of 10. Then we have 5, 5 2s are 10. And then we have 10. So 1, 2, 5, 10, these are all called as a factors of 10. So we can say that the numbers by which given number is completely divisible. So 1, 2, 5, 10, these are called as factors of 10. Let's look at another number, 20. So 1, 1 and that number itself, they will be factor all the time. Then you have 2, then you have 4, 5s are 20. So 4 and 5 is also factor. 10 is also factor. And 20 is also factor. So this is called as factor of a number. Now let's look at the multiple. So let's say we have written number 7. So you start writing the table of 7. So 7 1s are 7, 7 2s are 14, 7 3s are 21. It will continue like this. 7 10s are 70. Then again 77, 84. You keep adding 7 7. You will get the number which comes in the table of 7, or probably the number which is divisible by 7. So the numbers which are coming in table of given number. So when we say table, we just don't refer 7 1s are 7 to 7 10s are 70. It will continue like that, and that number, let's say 91. If you try to divide 91 by 7, what you will get? Remainder will be 0. So we can say that 91, all these are multiple of 7. Now let's look at the categorization of natural number based on divisibility of 2. So even number, any number which is divisible by 2 is called as even number. In simple way, you can do it. Any number ending with 0 or 2 or 4 or 6 or 8. So 0, 2, 4, 6, 8. By any of this number is there at unit place or the number ending with this, that is called as an even number. We can just write down 12, 14, 16, like that. It starts from 2, 4, 6, anything which ends with 2, 4, 6, 8 or 0. Let's look at odd number. Any number which is not divisible by 2. So when we say not divisible by 2, we can say that any number which ends with 1 or 3 or 5 or 7 or 9. So 1, 3, 5, 7 will continue like this. 31, 33, all these are odd numbers. So this is the categorization based on divisibility of 2 for the natural numbers. Now we will look at the categorization of natural number based on number of factors. So here you see we have written number 10 and we identified the factors of 10. So how many factors we have here? 4. So any number who has only 2 factors is called as a prime number. Any number who has exact 2 factors is called as prime number. And any number who has more than 2 factors is called as composite number. So whatever we have calculated 10, 20, these are having, this is having 4, this is having 1, 2, 3, 4, 5, 6. So these are all composite numbers, 10, 20. From maths perspective and for other topics also, when you do HCF, LCM or you do simplification, you will need prime numbers very frequently. So it is always good that you should be aware of prime numbers from 1 to 100. So let's look at this. 1, is it a prime number? If you look at the factors of 1, it has only one factor. So to have its prime number, we should have 2 factors. So it is having only one factor. So it is neither prime, it is neither composite. So it is called as a root number. Let's take 2. 2 is the only even number which is prime. So if you take any other even number, it is always going to be divisible by 2. So it will have factors more than 2, like 1, that number itself, and 2. So there is no other number than 2 which is even and prime. So let's just note down the prime numbers from 1 to 100 so that you can practice it and make sure that you use it in most of the things whichever way you need. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. Can we just count it? How many are them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So we have 25 prime numbers from 1 to 100. You have to remember it. You might need it in a probability or different kind of chapters. And when you will be able to find out whether the given number is prime or not, when you know the tables properly, then by looking at that number, you will be able to visualize. Like if I look at the number 71, if I know table from 1 to 30, I know that the 71 is not coming in any of the table. So I can easily figure out that it is a prime number. Yeah, and whenever it is having more than 2 factors, it is composite number. Then let's look at the rational number. Anything which you can write as P upon Q. So P upon Q, it's P is numerator, Q is denominator. P and Q, P upon Q, where P and Q are integers. So P and Q both will be integers and Q not equal to 0. That we need to remember. So P can be 0. So if I put some random number 2 upon 3. So 2 and 3 both are integers. So we can say that this is the rational number. We write minus 8 upon 5. So minus 8 is integer. This is also integer. P is also integer and Q is also integer. So we are good with this. I can write 0. So when I say 0, it is nothing but 0 upon 1. So this is also a rational number. 0 is P. P can be 0. Q cannot be 0. So if I put it like 1 upon 0, that will go as not defined, and this Q is 0. So this is not a rational number. Yeah. Now let's look at the irrational number. Anything which we cannot write it as P upon Q. So whatever is opposite of rational, we get that irrational. So whatever we cannot write as a P upon Q, where P and Q integers and Q not equal to 0. This is called as an irrational number. So if I write down the square root of 2, we won't be able to represent it in a format of P upon Q. So that is a irrational number. Square root of 3, that is again irrational number. If I write down pi, we don't have exact value of pi. So we cannot represent it as a fraction. The way we write it 22 by 7, this is just for our calculation. If we write just 22 by 7, this is a rational number. But that is just a workaround value for pi. Thank you.